All right, so again, welcome to Lab 5B, at least the virtual version of that. I know that many of you probably had to significantly change your lives in the last week. Some of you probably got kicked off campus, possibly voluntary or involuntarily. So hopefully you're doing well and had time to get out, and hopefully you're staying safe wherever you're at in the country or around the world. I'll start out with just a quick review of some notes I did this morning, and a few of you just finished up this afternoon. There might still be one person I need to touch up the grading for 5A. So overall, I just want to say that I appreciate you guys carefully following directions, carefully reading. It is hard for me to provide you with all the information and still make it educational, in the sense that I don't want to do everything for you. I still want it to be a learning experience for you. But it's hard for me to anticipate what you will need help with. And so you guys really did a nice job. I had a number of people reach out to me. In fact, a number of people just sent me messages or quick questions. So please continue to do that, especially with this week's lab. In fact, if I encourage you all, if you haven't yet done so, to take a look at the Blackboard gradebook and take a look at the comments that I made. I tried to leave some more in-depth comments, a lot more in-depth than I normally would when I was grading these, so that you can understand what was lacking, if anything. And especially going forward, you know, I think that if you don't take the time to read those comments that I made while I was grading, you might make the same mistakes over and over again. And they're mistakes that, had you been in class with me or with your partner, probably wouldn't have been made. So they're just things that, as we transition to a more independent learning with this course, it's in some senses I'm learning too, that this might be a little unavoidable. But please read and review those comments. And I also just want to give you the chance to, especially for if you're a little unhappy with the score, there were a few low scores, and I in some sense feel bad about that, but I don't want those to be repeated. You know, if it's just one score that's a little lower than you hoped, it won't affect your grade much in the end. But if you were unhappy with your score and it's a little lower than you thought, please take me up on my offer to send me a rough draft. Please, you can email that to me as a rough draft. Hey, could you just take a look at this? Let me know what you think. Much like I do at the end of a lab, right? Many of you were taking me up on the offer of having me take a look at your lab report or your spreadsheets in class. And it's really easy for me there to catch some mistakes, especially in your formulas in Excel, or mistakes in graph or formatting, or possibly just not understanding whether something is random or systematic error. Please go ahead and take me up on that offer to send me those rough drafts. Let me read through them first before you submit them on Friday night, so that we can catch a lot of those mistakes. That way we can get that grade as high as possible going forward. So please take me up on that. Again, if you have any other comments or questions on grading, I can address those individually. Certainly send me a message, email, Google Hangouts. General questions on how last week's lab went, go ahead and throw it in the chat section here off to the right-hand side of your screen, or wherever it is on your device. Feel free to do that. I'll give you a second in case any of you has any questions before we chat a little bit about Lab 5B. Just about everybody followed directions. I had a few people who did not send me their actual Excel file. I have contacted you individually, and so I think I've got all those. I just need to get a few of them in. So we'll follow with the same type of format, in the sense that you'll submit a typed version or a scanned version of your lab reports, and then you'll also send me the actual Excel file that I can load and view to make sure that the formulas and the graphing was done properly, as it should. I just find that that's a lot easier, and it's a lot more meaningful. I can tell that you're, I can even more easily troubleshoot where the mistakes are. Okay, so let's go ahead and take a look at Lab 5B. Again, I'm going to go ahead and assume that you've read through the Blackboard description for Lab 5B. I tried to give you as many videos as possible. There's actually 4 different YouTube videos to watch to give you some of the background information. We're talking about momentum during collisions, and we're talking about the impulse momentum theorem. And so I won't reteach you what's already in the YouTube video that I included. So it's a little bit of a different take on the conservation of momentum. It's a understanding that when we have a change in momentum of a system, it requires some exerted force. So we've done that in 2 ways: by bouncing a kickball off of a force plate, and also by a karate chop of a board. What's amazing, again, is that as I explained in the YouTube video, I do not have the arm or hand strength to be able to snap a 3/4 inch pine board in half. However, I don't need the force. What I can use is I can use a change in momentum to create that force. If I exert that change in momentum over a very small time with a quick collision between my fist and the board, by dividing by a small time, I can get a large force. So that's kind of the basic philosophy that we're following here. There's a little bit more Excel programming this week, and so I think we have to be brave and dive right into that. Give me just a second to switch over to the right tab in my window here, if I possibly can do that. I'll pull up the template, the Excel template that you guys will be using. Just 1 second. Okay, hopefully you are seeing what I'm seeing. I'll give it a second to kick in here. I sometimes don't always know if you're seeing this, but I think you're seeing an Excel template here. What we can see here is that, sorry about that, you have some data here that was taken in the same way that the data was taken with last week's Lab 5A. In this case, though, we just have one object moving. We have the X and Y position versus time. And as I'm scrolling down here, we have a much higher resolution camera. So you can see that there's lots and lots of frames between the first contact of that ball, that kickball, as it's hitting the force plate on the ground, and the last ball. So the last point of contact. So you have a little bit of discretion here in terms of what data you use. The data that I'm highlighting right now on the screen is the data you should be using to calculate the initial velocity. Right, we're going to use this, and we can extend our formulas down to this, but if we're looking for just the initial velocity, we're going to want to look for this part. If we're looking for the final velocity, we're going to want to look for this part. During this middle position right here, we have a changing momentum and a changing velocity. Of course, we go through some of the details for how to program in this area. Because we are really at the limits of the data collection abilities of the camera and the tracker software, we're really at the limits of the resolution here. There's a lot of random error in this experiment, and one of the common mistakes with last week's lab was a little bit of a failure to understand what random error is. If you zoom in, and you had to rely on me to do this, but those screenshots that I sent you, when you zoom in on the video, the screenshots of the video, you can actually see the pixels. So the fact that the tracker software has to search and find for the center of those pucks, or the center of this kickball, means that it has to pick one of those pixels. The pixel, one pixel or another, might not be in the exact center of the ball, but the computer is going to pick one pixel or another. This introduces randomness, or random error, to our experiment. It's unavoidable. Can we reduce it? Yes, we could buy a $7,000 camera that's got 30 megapixels and has a lot smaller pixels, but there will still be some randomness there. Zooming in doesn't really help because that just makes the pixels bigger. I'm not sure if you all realize that. Some people talked about zooming in, and that's a good idea, but actually what zooming in does is it just makes the pixels bigger. So high zoom can bring out those pixels. The point that I'm trying to get to is that we're going to use a data smoothing technique. We're going to take an average of the 5 data points that are nearby. That helps to smooth out any outliers by taking an average. We don't throw out the data. We're just taking an average of the 5 data points nearby. The lab procedure and the lab manual goes through that. Here's the data for a karate chop, not mine, but another student's in a previous lab that we have imported here. I also want to show you this picture as well, because this picture shows the alternate force method. We dropped the kickball on a plate that measures force. You can see that the peak amount of force here was 152 newtons as that ball bounced off the plate and then was bouncing back upwards in the other direction. So the maximum force that ball exerted on the plate, or the plate exerted on the ball, either way you want to think about it, is 152 newtons. I'll switch back over so you can see me here in just a second. So again, if you have any questions, please go ahead and let me know. Again, the lab report I tried to make as self-explanatory as possible. I attempted, I modified it from the normal version that we would have been dealing with to try to give you a simpler and yet still effective version, knowing that you haven't seen this experiment, you didn't experience it. If you have any questions, of course, you can reach out to me in the various ways that you have been in the past. Other than that, I don't have too much else to say. I just want to congratulate you guys on a successful first week. It was not easy for me to get that set up. I spent hours in the lab trying to gather the data. You know, it's really hard to do these experiments by yourself. I never intended that to be done. That's why we have you work in pairs. And so much less film myself doing it. So if it looks a little bad, I apologize. I probably made a few mistakes here and there. But again, reach out to me throughout the week. The physics of this lab is similar. We do have a little bit more. I would say it would be great advice for you to just send me, as I said before, a rough draft or a first attempt at these, especially if you're getting some numbers that don't quite seem right for your results. Why not just let me take a look at it? It'll take me 2 minutes. I can look for some common mistakes or formula mistakes, whatever the case may be, and then we can get them corrected very easily. I'll go ahead and hang out here for just a couple more minutes in case you have any questions you want to ask me in person. You can turn on your camera and your mic, or you can just type them in the chat message. Other than that, good luck. Best wishes this week as we continue our journey through the uncharted waters of college online.
I had a brief question. When you were talking about the data smoothing, is that done through like some sort of algorithm on Excel, or is it something we do like ourselves? I didn't quite catch that.
Yeah, it is a good question. So it is done through an algorithm in Excel that you program into Excel. So we explain how to do that in the lab manual. It's simply an average of 5 data points. You'll just simply average 5 cells together. And then you'll copy that formula down. There's no need to write 50 different average formulas, right? If you do an average of the 5 cells, in fact, if you're following along in your lab manual, I'm on lab B, page 3. It's on page 3 of this week's lab on the top of the page. We give you a screenshot in the lab manual of the algorithm and the Excel formula that you use. It's the average of cells E2 through E6. And then you simply copy that formula down. So yes, it's an algorithm, and yes, we show you how to do that. Good question. If we didn't do that, we would actually have some rather enormous amounts of uncertainty, enormous amounts of random error due to the well, it's really due to the pixels of the camera and just the fact that we're really at the limits of what the technology can provide. So,
Thanks.
Sure.